Hello and welcome back to a new video here on the Ludwig Fusel channel. In this video we're gonna take our C++ tutorial, the part where we just have written C, and move it to C++. We're gonna transition to C++ from C. And when I say we're gonna transition today, I'm gonna mean that, because we are gonna just transition today. We're gonna not start at C and we are not gonna end at C++. We're just gonna take the transition, like the glue between these two languages, and we're gonna glue them together, and I'm gonna show you my motivations, or the motivations in general that you should have as well, why we are using C++ and not C. So it's just a glue. We're not gonna do C, we're not gonna do C++, we're just gonna do a explanation video on why we do things. So without any more talking, let's directly get into it and talk about what we're gonna do today. Today we're gonna talk about 4 features that we miss in C but get in C++. So the idea here is of course not to name all features that are better in C++ than in C. There are many nuances and many complicated features and many more things that we're going to talk about today that are in C++ but not in C. But I have picked 4 big ones that I personally are like my 4 top points that I would come up with if you would ask me why are you using C++ and not C. These are probably the 4 ones that I would probably come up with. These are namespaces, object-oriented programming, structs and classes, so-called real objects, function overloads, and proper compile time code generations in C++ called templates. Now these are 4 big topics. I'm gonna talk about each of them in the next few slides, and we're gonna explain, or I'm gonna explain to you why we're gonna transition to C++ because of these 4 features. Now, of course, we are still not done in C. We haven't talked about everything that we can do in C. We haven't talked about everything that software engineering brings us. We haven't talked about all the standard library features of C. There are many things left open that we haven't talked about in C, like floating point, bitwise operations, many functions from the standard library, many architectural and software engineering things like proper linked list introductions, binary trees. We could have done all these in C, but still this is not a C tutorial, this is a C++ tutorial, so my idea here is to get all the main things done. For granted, bitwise operations and floating point would be something that might have fitted in somewhere in the C videos, but I didn't want it to take a few more videos to explain them, so we're gonna explain them later on in C++. Of course, these are not required to understand if you go to C++. It's not required, these are just optional things that you can teach in C or C++, and many things that I've done here could have also been explained the same way in C++. However, all things that I have explained, all the complicated stuff that I have explained was better to be explained in C than in C++, since C++ is complicated, more complicated, and is therefore harder to learn. Of course, if it's more complicated, it brings more features, which are 4 features that I've listed here. After we are done with these, I want to quickly also define the border between the C++ standard library and the C++ language, which is very important to understand. Alright, let's start by talking about the features that we miss in C, but get in C++. And basically you could name this whole section, why are we using C++, because if these features wouldn't be there, we wouldn't use C++. Alright, let's start by the first obvious one, namespaces. So before we can talk about namespaces in C++, we first need to see the problem that we have in C. In C we have the problem that every function name must be unique. So for example, we had the functions for the ini library, and we always needed to prefix them with ini underscore read from file, or ini pass data, ini do that, ini to that, ini underscore write underscore file, ini write underscore section. Like each name of a function, even though I made a few ones up here now, need to have their own names. Like common functions like write and read. You cannot just write and read, right? Because if you would write a function called write, you are highly in the risk of that somebody else is already calling his function write. And if you calling your function write, you're potentially getting incompatibilities with other libraries. So if you're writing a library, what I told you in C, you always want to prefix this with your library name, and if you're even going more nuts and your library is complicated, you should also divide your library into sections, and if you have then a write function, you have something like mylib underscore section underscore write to have a function that writes a struct to disk, for example. So really what's happening here is that we are clogging up the names of our function, right? The function should just write, however it needs to have the library name, it needs to have the section name of your library, and it needs to have underscores, and your function names are going to be blow up, they are going to be long, they're going to be complicated, and they are going to be hard to maintain, because nobody knows them. Everybody needs to always take a look on, oh, what's that function, everybody needs to type this down, and it's really not required. Right, for the function itself, the name right would just be sufficient, but we can't use it because we would clog up the global namespace. This is why this topic is called namespace. Every name is existing in the global namespace, so every name that you use of a function is like in one big pot, or if you would talk about the files, each function would be a file, and all files are in one directories, and of course you can't have multiple files with the same name. Now, what C++ does, it adds the concept of namespaces, or talking about the directory example here, the concept of folder. So basically what you can do is you can do hierarchical naming of namespaces. So by default, everything works like C. But what you can do is you can define a so-called namespace. We can talk about that later, how we do it. And what you can basically then do is you can create a so-called namespace. And everything that you're doing inside of the namespace is contained inside of that namespace. And of course, the namespace has a name because namespace name, haha, kind of like works. In this case here, for my example, I've provided this mylab .. section. This is how you write this in C++. So for example, your library is like the mylab, and .. basically means go one hierarchical layer deeper, and in this case we have section. Now if you want to reuse that function out of mylab section, you can always write mylab .. section .. right, and then you have access to the right function. However, for example, if you have another function inside mylab section which is called like serialized data, which serializes data to a file system, which at some point needs to write, you can just use the write function without any naming behind it, because we are inside the namespace mylab section. So you are inside the namespace where you want to use the other function from, and then you can just use the normal name because it's always going to be relative. The same with paths. If you are in a directory, you can just type the normal name of that file and it will open. If you're in a different directory, you need to type the full path to there, or the relative path. It's not working 100% like that. It's just working in one direction on C++, but the idea is basically that you can always navigate through namespaces. Same here, if you are inside of mylib, you need to call section right. While the global way, mylib section right, of course, always works. So the idea is basically similar to file systems, that you can always use the proper function, function in name, and you can write short code. So if you're inside the same namespace, you can just write the function right, and it's going to call the right one. If you're outside of that, you need to manually go in there. And that's exactly how file systems work, and how the magic on file system works, and the usability of them, and that's the same on namespaces here in C++ as well. Now let's talk about another problem, OOP programming, or structs and classes. Now in general, C itself is not object-orientated. However, you can do it. A struct is kind of like an object in C, even though it is not. It's mainly just a block of data that has a certain layout. However, you can abuse that certain layout to store variables of an object, and then kind of like abuse the struct as an object in C++. However, if you are doing this, everything needs to be done explicitly. For example, initialization. If you are creating a struct, it's always an undefined value. So we always need to call a function or manually assign the values so that they are proper initialized. It's not done automatically. We don't have a constructor or something like that. Constructor is like a function that initializes the data. In C++, we're going to have one that's called automatically, and on C, we need to manually write them and manually call them. So in general, every function needs to be manually implemented. Okay, we always need to do this, but manually created. Every function needs to be manually called, needs to be in the global namespace. And if you're doing this, you again have the same thing like mylab _section _mystruct _init, mylab _section _mystruct _add int, or without a section here in the example. So the names are always going to exist in the global namespace. Same issue as before. You always need to call them. You always need to remember to call them. If you want to add an int to that, you cannot just add it with a dot plus to a struct. You cannot like write your struct and then add a normal int on it. You always need to do it manually on the entry, so you need to write a function that does it for you, and everything needs to be done explicitly. The same here, I already talked about this, like a bit of this adding an integer to a struct. A struct in general does not support operators. Operators are like plus, minus, divide, multiply, array accessing, getting an address, pointer access, array access, converting it to values. This is all not working. Like these implicit conversions or implicit operations, then adding something on top of on top of existing data. This in C all works for primitive types. Only works for basic types. In char float, they all support plus, minus, divide, multiply. But structs in general, they don't. You need to write your own functions that do that for you. Of course, in C++, you need to do this as well. But in C++, you can do something called operator overloading. And operator overloading is basically you give your function a special name, and then it's automatically called when you are adding it into your struct. So you take a struct and say just struct plus 5, for example, and then it's automatically going to call this function. Same here with like the constructor to initialize data. Constructor is called explicitly. Constructor is called implicitly without any issue. Destructors are called, operators are called, everything is done automatically, and you have a real concept of classes. So the classes are basically a section of functions which can overload operators, can be constructors, destructors, functions that you write in general. These are all like functions that are associated with an object. An object itself is nothing more than a struct, basically, and the object is identified by having like the starting address of the object, which contains like all the data for that object, and everything is handled correctly, and you have correct objects, how you know it maybe from different programming languages. So you have data associated with functions that you can call, basically advanced structs, as I like to call them. And here comes the pun. In C++, structs are also classes, but that's something that we're going to talk about more in depth in the future videos. So in general, classes and objects, you can provide initial values, implement member functions. This is something that didn't work on C. On C, we were not able to write a function that operates on the struct. You always need to write a function explicitly and then take the struct as a pointer. This was not done implicitly. You always need to explicitly do this. In C++, this all works easy. And the nice thing is, same with namespaces, if you're using implementing a function for a class, then it's not going to be visible globally. It's just going to be visible for that class. But that's all something that we're going to talk about as soon as we are there. Yeah, that's basically how object-oriented programming in C++ work. Now let's talk about the function overloads. So function overloads, what is a problem in C? Every function name is unique, which basically means that we are only allowed to use one function name once. So one name, one function, one signature, it's fixed into memory, not into memory or kind of into memory, but it's fixed, and you can never change it. It's just one function name, and you can never ever use it again. As soon as it was used, you can only use the name once. Is this a problem? It can be a problem. For example, if you have multiple versions for one function. For example, let's imagine you have a function myfunc that can take 1, 2, or 3 ints, for example, like myfunc with 1 int, myfunc with 2 ints, myfunc with 3 ints. If you're doing this in C, then each function needs to have a different name, because one name is already taken up by the first function. So it's not allowed to name them all the same, but have different parameters. So you would need a myfunc, myfunc2, and myfunc3 to basically indicate, yeah, 1 parameter, 2 parameters, and 3 parameters, which in general is possible and not an issue. However, if you are changing your code, you cannot just append another argument or reorder the arguments or change anything on there, and it wouldn't work because you need a new function name. So it's not straightforward in C to have the same function name for different implementations. You always need to prepend something, append something to make this work. And this is also where a solution is there in C++, which is called function overloads, which basically means that you can take the same name of a function and have multiple versions for it. For example, here you have the myfunc with 1 int, the myfunc with 2 int, and the myfunc with 3 int. So the idea is that you have the same name, but different parameters. Of course, they need to be different so that the compiler can detect it. It's not like the idea that you have them with similar parameters. It always needs to be different parameters so that it works. But if you have different parameters, the compiler can detect which version you intended to call, just the way you called your functions. And then it's going to call the function with the proper arguments and the proper version. Now let's talk about my last example, which is like one of the most big PowerPoints of, or I use PowerPoint for the presentation, haha. The big power of C++, it is compile time code generation. Now, disclaimer, on C we already had that. On C we had the preprocessor, which we used to do like declspec import export. This is also a kind of compile time code generation because it's generated in compile time depending on how your project is set up. And there's also compile time code generation on C, and with hashtag defines of the preprocessor, they can be a bit more dynamic and decide how many arguments increments you have and stuff like that, but it's not proper compile time code generation. It's more like little utilities that help you wrangle around your code. What, for example, is a problem here would be the example of summing an array. If you want to write a function that can sum an array, you always need to do this explicitly for one type. So, for example, the function to sum in C would be named, for example, void sum int. And the idea of that function is to add the values of b to a, an array of two equal sizes. So what you would need to do is you would need to take 2 pointers, the int pointer a and the int pointer b, and the count. And then you would have a for loop starting at 0, going until count -1, counting up, and then you would say a at I plus equals b at I, which works very simple. It's very simple, right? Very straightforward, but as soon as you are having a different type, it's being an issue. For example, you want to sum up to char arrays. Well, you need to write the whole function again. You need to write void sum underscore char, open bracket, char pointer a, char pointer b, int count for int e, like equals 0, e smaller count, e plus plus, a from at I plus equals b at I, semicolon, closing the bracket. So you can see like the main idea of that function still stays the same. We just need to change the name and the types because we have C. So a function in the struct is always type dependent, and it's required to implement it differently if you require multiple types. Now, of course, C++ has a solution for that, and the solution is called templates. So templates basically mean that you want to replace the actual type with a placeholder, and the compiler generates the code at compile time. In general, it's just a smart copy and paste tool. However, it is more powerful than that. There are things like type traits and template meta programming that actually allow you to generate code the way you are writing other code. So you could write whole universal code that adapts on which type you're gonna give it. One of the most prime example is actually converting user-defined types to string. So you kind of like provide your own conversion function to convert your own struct to a string, like a print function for that struct. And then dynamically you can basically pass in every object into a function, and it automatically calls the right conversion functions. But that's a different topic. So just a simple example here. What if you want to use a template, we're going to take the same function that we had here. So the void sum with the pointers is the same down here again. Now the only change here is that we don't start with directly the function. We just start with a keyword template. Then we give it a type name t. This type name t is basically just similar to declaring a variable. So we are declaring the variable t, which is the so-called type name. A type name basically means take every type that you want to do and allow every type that the user might use. And then you can use that T kind of like as a copy-paste like template. In this case, we just use it here in the definition here. So T pointer A and T pointer B, because this is the only thing that was explicitly set to an int and really mattered for an int. The count always stayed at an int. And you then basically write the same function again. It doesn't look too more complicated. And in general, it just works like that. So you have just written it once, and now you can basically supply the type as soon as you are using that function, and then the compiler generates the code for you. So it basically sees, all right, I have this copy and paste parameter t. What type do I need now? I need that certain type. Okay, now I'm going to replace every t that I find with that actual type. Now you can see, for example, the usage. If you want to sum an integer array, you would call sum, and then in these pointy brackets here, the int, the type that you want to use, my a, my b10, or char, my a, my ca, my cb, and it would automatically generate the versions for an int and the char. And actually, there is something called, I don't know how it's called. So the idea is basically that if the compiler sees what your my a is, so the compiler can see your my a is a pointer to an int, then it would be automatically able to see, aha, you want to have the int version, so you would be able to just omit that int and these pointy brackets. But that's something that we can talk about if we are getting to templates in general. Alright, so these are all the main features that I wanted to explain to show to you why we only use C++. So many things that are important and easy, but we're gonna talk about them in detail when we get to them. Now let's quickly do one important thing that I want to do so that you understand the future videos as well. I want to quickly separate the language and the standard library. So C++ is divided into two parts, the C language and the C++ standard. So C++ is divided into two parts, the C++ language and the C++ standard library. We already had this in C, right? If you have included something with include whatever, you basically included the C standard library, and you use functions out of that C standard library to do certain tasks. And now basically the same as in C, we also have the same thing in C++. So C++ is the bare minimum language features, how the code is written, how the objects work, but not how they are implemented. So it's just the syntax. C++ is just the syntax. The language is just the syntax. However, if you are using predefined code, like what we previously used on C, which was our printf, this is basically coming from a library. We have the same in C++ as well. We have common functions and classes like printing, handling integers like uint 64t and these things. Of course, they are in C++ as well, and like many more. C++ does not only have, it's not as limited as C is. You have way more and way more flexible standard library in there. There are also like container classes where you can store data like dynamic arrays, hash maps, proper string classes, string streams, console I/O, operating system abstractions, for example, threads, hardware abstractions, for example, atomic values. It's also something that you probably never heard of that, but basically the standard library is doing way more than in C. It's not only providing a few basic functions, it's providing containers, operating system abstraction, hardware abstraction, and everything else. Now, of course, since the standard library is so big, we also want to have it in its own namespace, which in C++ is going to be called STD. Stands for Standard Template Library. I don't know. STD is, I think, just for standard, but it's like the Standard Template Library. It's like the big name. It's called template because it basically builds on the last thing that we talked about with the template, so it's more or less universal. But we're getting into that. Right, so common functions and classes and abstractions and containers, everything is inside there, the big STD namespace, and it's really, really useful. Alright, and that concludes the video for today. Thank you for watching. Make sure to like and subscribe, and we're gonna see us in the next video where we're gonna start and implement our simple C app, but a simple CPP app. So, thank you for watching again. See you on the next one. Bye!